All right. Good afternoon, everyone. We are nearing the end. Let's see. Week 18. So Strux, before we bring up Strux, so next week, I believe, is our last week. It's going to be our last week in the semester. Just a quick reminder. Okay, so the final is going to be held on the day that we are scheduled to take it, but it'll be available all day, just like the midterm, right? So there'll be a vocarium portion and a multiple choice. It'll be identical to the mid portion, except for the content. Of course, it is comprehensive. Another comment, you all should be getting a request for surveys soon. I would encourage you to please try to fill them out, good or bad. I do read those. I do read what you say, and sometimes that does often help. It does affect change in the class. I do often change the class due to your feedback. So one particular thing, one big change this semester was having the homework deadline on the last day of class. That's something I haven't ever done before. So maybe at least, give me your thoughts on that, good or bad. It can be a bad thing, right? Good or bad. But I would appreciate it if you would give me some kind of feedback on what you felt was good or bad about the class, what was beneficial, and what you think could be done better. All right. On that note, let us move on. Let's see. We are talking about Strux. Let's see. All right, what are structs? Structs, you can kind of think of a struct as maybe a fancy array. That's not entirely true, but you can almost think about it that way. A struct is basically a way for you to define a custom data type, right? You can define your own data type now. It's not an integer, it's not a float, it's not a double, right? This is your own data type, and the way you describe that data type is in terms of other data types, right? So what is this data? Well, it has an int and it has a string in it and it has an array and it has these other things. And this is your custom data type. And you can use this idea to kind of use this idea now to encapsulate more complex or abstract ideas like bank accounts, right? Maybe I want to make a unique data type that represents a bank account. And what does a bank account have? It might have a balance. It might have other things, right? And you can kind of define those data members within that data structure as well, other things. So how do we make a struct? Now, I'll go ahead and tell you, if you're doing this in Zybooks, they will do things slightly differently than what I do here. I cover a simpler version of using the idea of struct. So I don't actually go that last step and place this as a new data type. So if you go through Zybooks, they'll take one extra step that I don't do. And once you define your struct, they'll type def it. That's type definition. And what that does is it takes this name. So you see here, this struct type name, whatever you type right here, that is going to be the new data type name. They'll actually add that to the namespace of your program. So from that point on, you can use it just like int or double or string. You can just say, if this is my bank account, that'll be my bank account type, right? Or bank account data type. I don't do that part, right? So I don't add it to the namespace. They do. That's the biggest difference. And because of that, there are very subtle differences in how you interact with it. So the way you interact with the struct, if you do this, is different. So for one big difference is every time you want to make one, you have to use the word struct because it's not actually a custom data type yet. You haven't actually added it to the namespace. So we'll go over some others, but just keep that in mind when you're doing this and you're doing your exercises in the homework assignment that you get. This is the way I'm interacting with it, not the way they show you in Zybooks. It's good to have both of them, but this is simpler. So I try to stick to the simpler format. So how do you define a struct? Well, what we're really doing is we're coming up with a definition for a new data type. So you start with the word struct, and the very next thing you write should be the name of your data type. What do you want to call it? I want to call it something. So that's your data type name. Then you need the curly braces, kind of like with functions. And of course, you need the semicolon at the end. So unlike functions, you must put a semicolon at the end. This indicates the end of your struct definition. And then inside here, you just put other variables, right? The correct word for this is members. That's the technical word for the data members. But you could just put other variables inside. You would define other variables inside between the open and curly braces. Now, again, as I mentioned, if you define a struct this way, if you don't type def it, then every time you want to make a variable of this data type, this custom data type, you have to use the word struct. You can't just say my data type here. You have to say struct my data type, and then here's my variable name and the rest of it. So that's one small difference. Alternatively, one other thing you could do if you wanted to, when you define this, you can go ahead and create a couple variables. So in this example here, I am defining a custom data type. It's going to be called type name. I've got some variables, and I'm also creating one variable, and that's the variable name, some underscore name, right? So now I have a variable. It's a global variable, right? Which means I can access it anywhere. It's not restricted to a function because I didn't define it in a function. So it's a global variable. It can be accessed anywhere that has access to this file. But I already have one variable of this data type that exists because I did it this way. And you still need the semicolon, but now the semicolon would be after this. And just like with regular variables, you can provide a comma separated list. So you can some variable 1, comma some variable 2, comma some variable 3. You know, you can provide a list of variables if you want to that are all of this data type. The other thing you could do, you could just declare it inside of a function like main, like you would declare any other variable. So on the left here, we see a complete and actual struct definition, right? So struct, I'm calling it my struct. That's the data type. The data type is my struct. And this struct has 2 integers and an int pointer in it. That's what it's comprised of. I did not provide any variable names here, so I didn't make any global variables. And here in main, if I want to use it, I want to make some my struct variables, right? We would just say struct my struct, and here's my variable name. So that's the equivalent of doing int x or int y or string dog, right? You have a data type, but again, because I didn't type def it, you have to include the word struct. So these 2 things become your data type, struct, data type, and that's your variable name. And then the next thing you would have to do is initialize the member, give values to those members. And we'll do that in just a moment. So if we did it this way, then in main, we wouldn't actually have to do this because this variable would already exist. So here I made a variable called S1. But in this version, I already have a variable called my struct variable. So I don't have to make one here. I can use this one if I want to. Now, if I want another one, I have to make another one. But I could simply use this one right here, this global variable, if I wanted to. So exercise number 1, let's try to do this. And this will spin off of one of our very first homework that we did. Recall we did a homework, I believe we did it in here, where you had to calculate the resistivity of a metal, right? And you gave you all these properties and you had to come up with all these conversions and do it. What we're going to do now is we're going to make a custom data type that we can use to store all those properties. So now instead of having to pass all those things as parameters, I can just give you a struct. And all of those things are contained in my custom data type. Now you can just look inside my data type to get the information you need. So let's start by making a struct. We're going to call it metal properties. That's our new data type name. So we have a data type called metal properties, and it should have these things inside. These should be the members, the data members of our struct. we do have pointers. So we should also include the standard library so we can do pointer stuff later when we need to. You don't need any special libraries to work with structs. Right. So first of all, we would not define the struct inside of a function, okay? It has to be defined outside of a function. So you can use it from all these functions. So you would not provide the struct definition inside of a function. Typically, you'd put it in the header file. The struct definition will go in a header file, but for us, for this exercise, we can just do it right here. So we know we want to define a struct, and that's what we want our data type name to be, metal property. So we can do what? Struct, right? Our keyword. Here's my data type name. And then at least I need that. I at least need this much, right? So now I have the shell for my data type definition. I just have to add my data members, right? And that's pretty straightforward. To add our data members, what do? Well, we can just, bless you. To add our data members, we just literally declare these variables. That's all we have to do. We just write a bunch of variable declarations. So character pointer for metal name. Oh, it's a double. You know, let's do this. I don't want to write so much. Resistivity number. Double R power. Double length in meters. Double radius in millimeters. Right. So now we have a custom data type defined that if we wanted to, we could create variables of this unique data type if we wanted to. So how do we initialize the data members? How do I put information in those things? Well, there are two ways. If we are dealing with an actual struct and not a pointer, so let's say we wanted to make one of these, right? So someone help me out. How could I make one variable of this data type, the metal properties data type? How can I make a variable of this metal properties data type? That's right, my variable name. So struct. And if we had type def that we could just type this, but we didn't. So struct, that's my data type name, and that's my variable name. So now I have a variable, but it doesn't have a value, right? That's kind of like doing int x. I got a variable called x, but I don't have a value yet. So the way I give this struct a value is by providing values to all of the data members in the struct. And the way you do that, you can't just type in, for example, the variable name, right? Because that doesn't exist. That variable does not exist, at least not like that. If I want to access that variable from within my struct, I have to type in my struct variable name and then use the dot notation. So period and then X. So if I want to get to these members, it's the variable name dot the struct variable name dot data member variable name. Right. So we can see, we can do some of these right here. If I wanted to do, for example, well, we'll come back to that. So here we can see we have X, Y, and a pointer for P. So you have X, Y, X equals 10, Y equals 1. Aside from that, once you access the variable, you change it just like any other variable, and you use it just like any other variable. Right. So the only difference is that in front of that X, I have my struct variable name and a period. That's it. That's the only difference. Pointers, even pointers behave the same way, right? You're still going to call malloc. You still have to do the same thing. It's still a pointer, right? How do I interact with it? The same way I interact with any pointer. I just have to put MS and a period in front of it. This is how you would normally use a pointer. So nothing really changes, except for the fact that in order to get to that variable, I have to go through my pointer variable. You can think about it that way. So pointer, period, whatever the data member name is. So if thinking about the previous slide, this is how we could give it values. If we wanted to access the values or change them again, right? ms.x, ms.y, ms.p. What this should say is, how do we dereference pointers? That's what this should say. So how do you think, given what I've said so far, if you had to guess, given what I've said so far, how do you think we would dereference p? We know p is a pointer. And this is how I allocated space for it in the heap. How do you think I would dereference that? Say that again. Well, where would I put it? Okay, that's a good assumption. But we would dereference it kind of the same way, right? We still need the asterisk in front of the variable, but remember, we can't access this variable directly, right? We have to access it through the struct name. So technically, this entire thing here is the name of our variable. It's not just p, it's ms.p. That whole thing, let's call it a fully qualified name, right? So in order to do it, I still have to dereference it. Whoops. I still have to dereference it, but I have to dereference this entire name. So you would put a parenthesis around this entire thing. It does mean something different if you don't have the parentheses. So you do need the parentheses and you put the asterisk here. But aside from that, you use it the same way. You still have to dereference it. Just put the asterisk in front of the fully qualified name and put parentheses around it. So exercise number 2. Let's go ahead and try to put values into each of these data members. Now that we know how to access them, right? Let's go ahead and put some values into each of the data members in our struct. And here's what you could put in. Here's a hint, string copy. Actually, we need the string library here. So include string.h. It's just a lot less painful. So we don't have to, this is a character array. Who wants to put one character at a time in an array? That's really painful. If you use the string library, you can use this special function called string copy. And you can just give it a string and it'll copy it into the array. We can go ahead and actually do that here. Well, let's start by allocating memory for that, right? So metal metal name equals malloc. And if we want to do, let's say, copper, right? We know we need 6 spaces for the word copper and 1 space for our null terminator. So it's a malloc, we'll just say 7 bytes, size of int times 7. We could make it bigger. Let's just make it bigger. It doesn't have to be an exact fit. If we don't need to use all the space, we just won't use all the space, but we'll have some extra space. And then to put something into it, right? We're going to use the string copy function and we'll give it our pointer variable and we'll give it the value we want to put inside there. So we could say something like this, string copy, and we'll give it our pointer variable. And remember, the way we access it is through our struct variable, right? That's my struct variable name right there. So that's my pointer variable. And then what do I want to put in it? We'll just say copper. And we could print this just to make sure that we actually did put the right thing in it. And we're going to do, how do I print that? How do I access that? Now we just gave it some memory. We just put a value in it. Now I want to print this string variable using a printf statement. What do I put right here as my second parameter? That's right, mp.metalName. Very good. I have to include, remember, this whole thing is the new, let's call the new name for that, right? The fully qualified name for that variable. It's the struct variable name plus the data member variable name. And if we run it, sure enough, There we go. We can see we put copper right there, which is what we should have done. All right, so I'll give you all some time to populate the rest of those data members, right? We want to put these values in it for now. And we can do some of this together, right? So why don't we go ahead and let's see, MP, and we have resistivity number equals 1.7, right? So MP resistivity power equals -8. MP dot length in meters, we're gonna say 80 meters. MP dot radius in millimeters, gonna be 5 millimeters. And we could just print all of this to make sure that it works, right? So we can say copper. Let's see, we're gonna do, these are all doubles. 1, 2, 3, 1, 2, 3, 4. And we are going to put what? Middle name, MP, MP, R power, MP, lim, MP. All right, so let's just see if we did actually successfully put something into that struct, into those data members. And if we run it, sure enough, that's exactly what we should have done, right? So we've got copper, resistivity, number and the power we want to raise it to, length in meters and radius in millimeters. Very good. All right, so far pretty straightforward, right? We should know how to how to define a struct. This is my custom data type definition. We should know how to declare one, how to make a variable of our custom data type. And we should know how to access and or modify the data members of our struct. That's the individual variables that are inside that struct that we just created. So what changes when we deal with pointers, right? So just like we can have, regular variables, int x, we can have pointers that point to those regular variables as well. So pointers, you're not limited to pointers that only point to default data types. You can have pointers that point to these custom defined data types as well. And for the most part, they will behave exactly the same way as a regular pointer does. Sorry, as a regular pointer does. So if I wanted to make a pointer to a struct, we would start the same way. Here's my data type. Here's my asterisk. Here's my variable name. So you start the same way. You have to malloc space for it, just like you have to malloc space for any other variable. So malloc size of, and your data type now, instead of int, it's going to be your struct because that's your custom data type. The only difference is going to be how you dereference it. So this is the one thing that's different. Typically, when you're accessing struct items, we're going to do it like this, right? With a period. It's going to be struct variable name, period, data member. But when you have a struct pointer, instead of a period, you use an arrow. That's the only difference. Everything else is identical. The only difference is that when you're trying to access the data members, if you have a pointer, you use an arrow instead of a period. That's it. So I know I've said it a couple of times. I'll say it one more time because people always get confused here. The only difference between interacting with a regular struct variable versus a struct pointer variable is that the struct pointer variable, you use an arrow instead of a period. That's it. Everything else is the same. I'll get down to the P member, same answer, right? We still have to dereference it. You still have to put the parentheses around everything, but instead of a period, you have an arrow. That's the only difference. So let's repeat that last exercise, but this time, let's do it with a struct pointer variable instead of a regular struct variable. So instead of doing this, let's make a struct pointer variable to do that. So let's make one, let's say, we'll do it down here. So struct metal property, this is my data type, asterisk indicating I want to make a pointer, and we'll just do metal properties pointer, right? So I have a pointer variable. So that's the only difference. Repeat this, but do it with the pointer, not just a regular struct variable. Do it with a pointer. All right, we can do some of this together. All right, so to start with, we have to do what? What's the first thing we have to do before we can start putting things in our struct? Because we have a pointer now. What do we have to do with pointers? Huh? Ooh, that's right. We have to allocate memory for it. So pointers don't start off with space. You point to an address, but it's not pointing to anything right now. So the first thing we have to do is allocate some space for it. So here, and how do we do that? How do we allocate space for pointers? We're going to use malloc, right? So nothing really changes just because we're dealing with structs. We're not doing anything different. We still have to do the same kind of stuff. So malloc, and we need size of some data type and some amount, right? If we wanted a dynamic array, we'd have this times some number, but at least we need a data type. So how big is a metal properties struct? We'll do size of what? We don't know how many bytes it is off the top of our head. We could count, I suppose. What goes in the parentheses now? Size of what? So here's a hint. What's that? That's right. This is my data type. So before, like if this were, for example, if this were an integer pointer, right, that would be size of int because that's the data type. The data type is integer. But now this is not an integer pointer. Our data type is metal properties. It's a metal properties pointer. So we need to make enough space to store one of those things. However big that is, you tell me how big it is, that's how much space I need. And actually we could see, let's see, printf the size of, let's just see how big it is. Warning, long inside in, that's fine. It is, oh, it's actually pretty big, 40 bytes. No, 40 bytes. So that's the total size that it takes to store all of these things. All right, and let's start putting stuff in here. So I've got enough space to do that. Now we are still dealing with a pointer struct. Let me see. We are still dealing with a metal property struct. So and there's a pointer in here, so I need to allocate memory for that. So how would we do that? How would we allocate memory for that thing? So metal properties pointer. How do I indicate that I want to malloc some place in memory for that variable right there? Okay, so that's how we allocate enough space. So size of character times 7, right? Because I need, oh, we'll just do 20. We'll do it, make it bigger than we need. But what am I missing? MP pointer, that's my metal properties pointer variable. I need to put it in here. How do I tell it I want to malloc enough space for that pointer? There you go. Instead of the dot, we do the arrow. So we do it exactly the same way we did it before, except we use an arrow instead of a period. That is the only difference. That is the only difference. Use an arrow instead of a period. And then we can string copy, just like we did before. String copy. But again, my pointer. Here is my, that's how I indicate that variable. And then we just put, copper. This is no different. That part's still the same. And then we could put values for the rest of these, right? Pointer, arrow, rnum equals, what did I put for the other one? 1.7, MP pointer, R power equals -8. Pointer, arrow, IM equals 80, MP. As you can see that for the most part, these are identical, right? So the only difference is instead of the period, we're using the arrow. Except for that, it's identical. And we could even, if we were to do, even do the same print statement, if we wanted to print this, and we'll do now, it's going to be MP pointer. And again, we'll change that to an arrow. So instead of a period, we'll use an arrow. It's the only difference. They are identical except for that. So let's compile it. MP undeclared. What happened here? Oh, it doesn't like those brackets, huh? Well, okay, that's interesting. It's never been an issue before. All right. And if we run it, we can see, let's clear this. Go away. Oh, hey, what happened here? Uh-oh. Okay, what do we do? Metal properties. This should be printing stuff. Oh, whoops. Okay. I did all of those operations before I actually had any space for it, and then I made space for it and wiped all of that out. So let's see what happens now. There we go. So sure, and we should put an extra space here. Right, so we can see now. Very nice. So next question now, considering what we've seen so far, we know how to make a struct. And we know how to populate that variable with values. We know how to make a struct pointer, and we know how to populate that with values. If you had to guess, how do you think you would create an array of structs? Take this one, for example. We can use a concrete example. What if we wanted to make an array of this kind of struct? How can I do that? Remember, it's just a data type, just like int or double or float or anything else. How do you think you would make an array of that struct? These should be very intuitive answers, I think. The same way you make an array for any other data type. Very good. Hopefully we're seeing a theme here, right? How many times that same way you do it for everything else? It's just an array, and this is our new data type. Instead of int, it's just struct, my struct. This is our new data type. That's my array name. That's how many of these structs I want to hold. I want to be able to store this many struct variables. And you would access it just like you access any array element. So element 0 is our struct, and element 0 in this example has an X and a Y and a P. So previously, our struct name was MS, right? So it's ms.x, ms.y, ms.p. Remember how arrays work though. Arrays are nameless variables. Array elements don't have names. They're variables that don't have names. But the way you get to them is by their address, by their index. So this is at address 0. So I go to element 0.xyp, element 1.xyp, element 2.xyp. And this, aside from that, this behaves the same way. If you're referencing pointers, just like any other pointer, you put the parentheses around the whole entire thing and you dereference it. So the struct is still the struct. An array is still an array. They still behave the same way. Both of them do. So let's take a little bit of, well, let me do this and then we'll do the last exercise. So quick recap. Structs can be used to define new data types that consist of one or more mixed data types. So a struct has variables inside of it. They can be different data types. They don't have to be the same. If you want to access those variables inside of a struct variable, if you create one, you use the dot notation. If it's a struct pointer, you use an arrow instead of the dot, but everything else is identical, right? So regular struct, period. Pointer, arrow. That's the only difference. If you do make a struct pointer, and again, this should be intuitive, just like any other pointer, you have to allocate storage for it. If you make any pointer, it has to point to something. If you don't point to an existing variable, you have to allocate storage using malloc or something like that. Structs are no different. They're just a different data type. You still have to allocate memory for those two. And finally, if some of your data members, some of your struct data members happen to be pointers, well, just because it's a struct does not change how pointers behave. Pointers still need memory. You still have to allocate memory for that thing. All right, so last exercise. Why don't we try to redo well, we probably don't have time to do that. Let's take this as a self-study exercise. So remember homework, I think it was homework 1 or 2, probably homework 2, where we had to do the metal properties and we wrote a function, right? We passed all those things as parameters. So now, instead of having a function that would accept those parameters, rewrite that function so that it accepts a struct, and then just execute that same code using those struct members. And then version 2 of it, instead of just passing one struct, pass an array of structs. So that function can execute and calculate or print the resistivity for every single metal that's in that array, right? Because now you have all the properties for multiple metals, and you can just go through the array and print the properties for all of them. And with that, do you all have any questions for me? All right, no questions. I'll see you all on Wednesday. Have a good evening, everyone.